Okay, again, x1 to xn are ID, and x is either 1 or minus 1. And I have a y is the summation of x, and then divide by the square root of n. So now first I want to show the expectation of y equals 0 and variance of y equals 1. So expectation of yn is expectation, this just going down here, summation I from 1 to n xi. That means take 1 over square root of n outside. Expectation summation I equals 1 to n xi. I could take the summation, I'll switch summation and the expectation. What happened? I know the expectation of x is either 1 or minus 1 with equal probability. Okay, so that's the summation I equals 1. No, there's no summation. Expectation. Now that's 1 times 1 over 2 plus minus 1 times 1 over 2. Equal probability. I still have like I equals 1 to n here. And this is 0. Now done. Next one, variance. Okay, variance of y is just the variance of the summation of xi. Since there's a coefficient here, so I put it outside, there'll be square it and the summation, the variance of xi. And the variance of xi is the expectation of xi square minus mean square which is summation of 1, I from 1 to n, which is 1. Now find the moment generating function of yn. It's the expectation of exponential syn. And now is x1 plus x2 plus to xn. And this, they are ID independent, so I can put the multiplication outside. And since they are ID, they are the same. So actually it's the expectation n times n, so there'll be to the n. And now we want to find the expectation. The expectation is equal probability. And now we take 1/2 to the n outside, and this one we use Taylor expansion. And after the third times, I don't care, so I can put this here. And also the second term, type Taylor expectation finally this is 2 plus 2 s squared divided by 2n to the n, which is 1 plus s to the 2n to the n. If n goes to infinity, by lecture notes, you finally found this goes to e to the s squared divided by 2.